Okay, BYP back in the saddle on the Hewlett-Packard 8660 control head. I've taken a break to do some things that I can't tell you about because they're heading for patent land, but I don't like leaving assemblies like this unfinished for an extended period of time. I tend to forget what was done to them. Used to have trouble with that, doing complex work on VCRs and camcorders, take them apart, have to wait a month to get the parts, have no recollection of what we did to them. So, returning to recapping these boards after having to order some more tantalums, have the correct soldering iron in place, and the correct soldering iron is this 15-watt iron on a temperature control, not a 30-watt iron with a more massive tip. And got the, pardon my manual focus, the capacitor meter and a coffee ready, so I'm good and jittery and ready to go at it. If you'll notice, these boards are in edge card connectors, and I've been pulling these bigger boards out, taking components out, soldering new components in. Took the boards out by pulling up. I got to thinking I better stop doing that. This is an old assembly. I'd made a mistaken assumption that these are double-sided boards. They're not. They're multi-layer. And I realized that the procedure I was doing to unsolder the old component and solder the new one in subjected each solder joint to maybe at least 5 heat cycles, which is not good on a multi-layer board. So from here on out, I'm going to change the way I did things and hope I didn't damage anything. The way to take these boards out is not to pull them up, is to use a screwdriver while grounded, grounded mat, and pry up here. The withdrawal forces between the socket and the edge card connector, not the board beneath. And the correct way to get these out is to do this. Now, there may not be much clearance under here. It's possible to reach up on this one. I was able to reach up from underneath by lifting the unit up and lift up underneath and get the screwdriver back here and pop it up. Once there's clearance, just ratchet it up. That's also less time that your hands are in contact with the board, and then it pops loose. Take that puppy out, put that puppy down, and we see it's the one that I've already done the solder work on. But you see that I've soldered the components lead right to the board. That's a lot of heat stress. And it's localized heat stress, which is even worse. When these boards are processed in bulk, the entire board is soldered all at once after a preheat, so the board isn't subjected to severe mechanical stress. There's no way to replicate that at the workbench. So what I'm going to do is, instead of this, I'm going to do something else. And that something else is whatever it takes to not subject that to excess heat. So I'm going to reach back here, I haven't done this board yet, and pry that one up. Pry, touching the traces as little as possible, and take that puppy out and observe. There's a tantalum. There's a tantalum. There's a tantalum. They might be good and they might be hand grenades. There's no way to know. So the thing to do to minimize the heat stress on this board, at the end of the focus range, is, instead of removing the component entirely, take the new capacitor with the wire leads and use pliers to form hooks on the ends of the leads on a new capacitor and hook them around the wires on the old capacitor and solder the new capacitor leads to the old capacitor leads, which will leave 2 capacitors in parallel, which is not acceptable. That still leaves the voltage stress applied to the old capacitor and increases the capacitance, and increased capacitance is not necessarily good, because that'll make a much larger transient at startup when the power supply comes up. Now this capacitor, the leads are fairly short. Some of them on the other boards have much longer lead length, but there's enough there to get it done. So solder the new across the old, leaving enough room between the old wire lead and the body to come in afterwards with cutters and cut one of the old capacitor leads and pull up out of the way so it's not in contact. Then repeat as many times as necessary to replace all the capacitors. So there is the big difference between my channel and knowledge and almost anything else you're going to find on YouTube. Enough experience here to know when I'm doing something wrong. Most of them don't have that, and they'll just blindly forge ahead telling you to solder and cut and pull and tear and do whatnot. Maybe they can get away with it, but the penalty for damaging something like this is a whole lot more severe than they can ever deal with. So hopefully I've not done any damage to this unit. This is just a control head. I started here. It's just digital logic ICs and mechanics. I didn't start with the RF sections first for that reason. This is a bit less tricky to deal with. So if I made the mistakes, I made them on a unit like this, which is easy to pull out and work on. So bon voyage, happy soldering, Kate BYP.